we will see how we can design a combined parallel port interface. So the combined parallel port interface should be able to support both input and output operations of the device. So it means that this interface should be able to accept data from the device, and this interface should be able to write or give data to the device. So if you see here on the top left side, we have pins from D0 to D7. They are used by the CPU or the master to feed or take data from this input interface. Then we have pins from PA0 to PA7. They act as bridges to get data from the device when the device is playing an input role or the input device role into the interface. Then PB0 to PB7 takes data from the interface to the device when the device is performing an output device role. Okay, so these are the pins on the device side as well as the pins on the master side. Then we have additional pins for signaling. The pins CB1 and CB2 are actually the corresponding pins of pins valid and idle that we saw for the output interface. They are directly connected to the handshake control unit. Then we have a pin CA that plays a role of valid pin or the valid signal in case of the input interface or when the input operation is happening. Then we have our usual signaling pins, master ready, read or write. Then we have the address pins and we have slave ready signal too. And the next important thing about this interface is this interface has got three addressable regions. One is data in, that is data out, and the last one is the status register or the status bits. So these three regions can be separately accessed in any operation. So suppose that we need to access this entire interface. What should happen is this address decoder should flag a 1, or it means that if you see this design here, the MSB 30 bits of the address actually helps in selecting this entire interface. So the rest of the 2 bits A0 and A1 are used to select between data in, data out and SIN and S out. As there are 3 commands, we require minimal of 2 bits for selecting between them. So this is a rough idea of this interface. Now we will go through the various operations possible in this interface. The first operation is the reading the status bits or the contents of status register. So here there are only 2 status commands, SIN and S out. When the device is acting in the input interface role or the input role, SIN indicates whether the device is ready with an input, and when the device is performing an output device role, S out indicates whether the device is ready to accept data from the master or the CPU. So these are actually tri-state buffers, and the corresponding signals SIN and S out are limited or controlled by these tri-state buffers. So these are their control lines, and if you see these control lines go to this AND gate marked in green. So the activation of these status bits or status register contents depends on the activation of this AND gate. So we need to know when this AND gate can be triggered. So obviously we know master ready signal is necessary for this entire device or the entire interface to function, as it is wired to all the components. Then as our operation is a read operation, in the read write section we should give a 1. Then the next important thing is this entire device entire interface should have been selected, or it should be or the address intended by the master should be of this interface. So that is determined by the upper 30 bits of the address given by the master. So the upper 30 bits are fed to an address decoder, and if it gives a 1, then it can be any of the components within this interface can be selected. Then in order to particularly activate this AND gate, what we should know is the bit patterns to be applied to A0 and A1. So if you, after careful observation, we arrive at the thing that A0 and A1 should both be set to 0 to select this AND gate. Okay, so this is how we will perform a reading of status bits. So when this AND gate is triggered, the corresponding control lines of these buffers will get activated, and SIN and S out, as the case may be. Either one of them will be available across the line D0 to D7. Actually, both of them will be available across as per the needs. And if you see here, S in is actually clubbed to D0 and S out is actually clubbed to D1. Okay, as we have two status bits, they are clubbed to two different lines. So this is how a read operation of the status bits can be done. Next is how this device can act as an input interface role, or how this device can work in an input interface role. So we know that the data in register, or the register acting as the input register for the device, is actually coupled to the lines on the master side or to CPU side through many tri-state buffer circuits, right? And all the control lines of these circuits are grouped together and it is made to go to this AND gate. So activation of this green colored AND gate is responsible for the interface to act in the input interface role. Okay, so we need to know when this AND gate will get triggered. And as usual, for any operation to happen within this interface, this interface has to be selected, so that this decoder should give 1 or the uppermost 30 bits, right? Or the 30 bits of the MSB of the address should be of this interface. Then the master ready signal should be there. Then read or write operation, as the case may be, should be properly specified. Here it is a read operation, so the line has to be 1. So after all these conditions are met, there's a fair chance that this AND gate will get selected. And the only remaining thing is regarding the status of A0 and A1. And after careful observation, we can find that if A0 is turned to 1 and A1 to 0, we can selectively get this AND gate activated, and it means that all the tri-state buffers will be triggered, or that output pins of data in will be coupled to D0 to D7, and hence this entire interface acts as an input interface. Now we will see the next operation possible for this interface. So this interface, let's see how it can act in an output interface role. So as I said earlier, first step is to select this entire interface. So that is made possible using the upper 30 bits of the 32-bit address. And once the decoder recognizes that address as the address of this interface, we will get an output at the address decoder as 1. Then the master ready has to be activated for any of the operation to take place. And here the operation that we intend is a write operation. So the read or write pin should be 0. So almost all the conditions required to activate this AND gate is okay, but provided the status of A0 and A1 lines has to be determined. So if you observe here, in order to activate the corresponding lines from A0 and A1 incident on this AND gate, we have to keep A0 as 0 and A1 as 1. So when this condition is met, this AND gate will be triggered, and the triggering of this AND gate will actually act as a clock or a rising edge to data out. And data out is our output register, which already might be having the content that was written to by the master or by the CPU. So on seeing the active edge, it actually closes clocking in of the contents from the master or from the CPU, and later when the device is ready, it can take out the data as intended. Okay, and the next remaining thing is the state of slave ready. Okay, how slave ready will be activated? So slave ready will be activated when this device is selected by the master and any of the operation is specified to this device. So it means that if we observe triggering of any of these AND gates which corresponds to various operations across various regions of this interface, it means that slave ready should be triggered. So either the AND gate corresponding to reading of the status bits are to be triggered, or the AND gate corresponding to the input data register should be triggered, or the AND gate corresponding to output data register should be triggered. So triggering of any of these AND gates will be a reason for the slave ready signal to get activated. So this is actually the rough overview of the combined interface. Now we will see what all optimizations can be possible in this combined interface. So one optimization possible is to reduce the number of bit lines exposed on the device side. Okay, earlier we saw that we had two pairs of 8-bit lines on the device side for input and output purposes. Suppose that we are going to couple both of them to a single 8-bit interface line. So what all extra modification should be done? Okay, so this interface is a combined interface. It is capable of supporting input and output. So we can see input data register and output data register, and here in this case output data register is coupled to a set of tri-state buffers and whose control lines are controlled by data direction register. So the bit pattern present or set within this data direction register determines which all of the tri-state buffers will get activated. Okay, suppose that we are setting this bit pattern on the data direction register, which means the MSB is 1 and the LSB is 1. So it means that only the MSB and LSB of the data out will be properly allowed to pass through this tri-state buffer. So only the tri-state buffer corresponding to MSB and tri-state buffer corresponding to LSB will be activated. So when this pattern is fed to data direction register, what happens is at P7 you will get the 8th bit of data out, which is 7, right, out 7. Then at P0 you will get the first bit of data out, or is out, or the out 0, and the remaining bits are the bits used for data in. Or it means that here we have got an extra capability that simultaneously certain lines on the device side, right, can be used as input lines, and certain other lines can be used as output lines. So once this pattern is set into data direction register, it means that the MSB line and the LSB line are exclusively used for output purposes. That means the data from data in, that is, they can't be used to carry data into data in, but only used to carry data out, data from data out. But the remaining lines from line number P1 to P6 are exclusively used as input lines, and device can use it to send data into the interface. Okay, so this is the role of a data direction register, or this is a generalized interface actually, right? This interface can actually work for any configuration of pins on the device side, right? Any pin can be made as an input or output pin based on the setting of the data direction register, right? Then we will see the extra modifications done on this interface. We have two lines C1 and C2 also facing the device, right, and they are actually responsible for performing handshake signal as well as the setting or checking the status of the device, and it is sent to a status and control unit, right, and this unit is responsible for raising an interrupt to the CPU or to the master when we interpret or when we encounter various situation of the status of the device. Then here in this interface representation, the address of this device or this entire interface is given as a single line, even though they are composed of multiple bits. And when this address is of this entire interface, what happens is this entire interface will get selected. Then we have RS0, RS1 and RS2 lines, which help us to select between the various modes of operation of this input interface. Okay, if you want to select data in a particular pattern should be given across RS0 to RS2, then again we have the option to select another region data out, and we have to select also data direction register, right, now to set the pattern. So actually there are 5 addressable locations within this general interface, that is data in, data out, data direction register, status register and control register. Okay, so in order to select between the 5 addressable locations we need at least 3 bits. So RS0 and RS2 are known as the register select lines, as everything is in the form of a register within the interface: data in, data out, data direction register, then status register and control register. Similarly, we have certain ready and exit pins also facing the CPU side or the master side. They are used for asynchronous protocol support. Then we can see read or write lines. So this is actually a modified or sophisticated form of a combined interface that we saw in the earlier figure. right? This interface is actually shown in a much less complex and flexible form.